All right, this is going to be Algebra 2, Lesson 1-7. We are solving system of inequalities again. This is the more challenging version, and by that I just mean there are more of the equations to look at. All right, so we're on Standard E. What is Standard E class of Ben and Arrow?
Solving systems of inequalities.
Yep, systems of inequalities still. Just a note, this is the first video where we have the warm-up included in the notes, so that will be up online to not miss points on the warm-up. All right, so today's notes are really short. I just want to do one example and then I'll release you guys. Once you can do one hard example, I know that you can do the rest. So all we have is example, and there's no summary today. Unless there's something key that I think that we're missing. So here's our example. Let's do our curly brace. I want 3 functions to go in here. The first function, I'm going to color code these two. So my first function is 3x plus 2y is greater than or equal to 1. My next function, I'll do it black, is going to be 2x plus 3y is less than 2. And my final function, my third function, is just going to be x is less than 3. So a really helpful tool, if you don't like these forms, is to convert them into a form that's better. Do you guys have a favorite form? Do you like slope-intercept form, y equals mx plus b, or do you?
Yeah. Slope-intercept form is the best.
Okay. It is the best until you hit calculus and you realize that that's another 10 seconds that could have been saved for another problem if you knew point-slope form. So point-slope form is used in calculus once or twice. Slope-intercept form is used still mainly. All right, let's convert these into slope-intercept form then. It's going to be a y is greater than or equal to. Go ahead and do it on your own, and then you can check on the board to see if Mr. Sindel messed up. All right, did we get the same thing? Ben's still working? Okay. I need to undo this. All right, so in here, I want to paste my graph paper and graph these guys. So go ahead and set your graphs up. You can sketch these, you don't need to make them perfect. So I'll make my axes slightly larger. And I can tell that they are all going to be pretty small. Maybe I can make everything in terms of sixths or something. I'm not sure. Well, we'll see, I guess. All right. Let's do our first function. Go ahead and do it in your own book. Make sure you're doing it right. For the blue function, and this is kind of a note, and sometimes the textbooks don't even do this, so I don't feel like I need to make sure that you guys do this. But whenever you have a less than or equal to or greater than or equal to, usually you do solid points to graph the line. But for example, the black function, this one, if I was making the points, I would like to make the points open. Those aren't actually the points, and then connect them with the dotted line, just to let me know that I can't actually be equal to that point. But again, the textbook doesn't do that either. On the dotted line, it just does regular points and then makes it into a dotted line. All right, so.
Are we solving by graphing?
Solving by graphing, yeah. So when we solve a system of inequalities, you always solve by graphing. It's too complex to actually solve with just algebra. All right, so begin. So I'm going to scale mine a little bit differently, just because otherwise it's going to be too hard. Yeah, I can scale by half. I'm going to say this is 1/2, this is 1, this is 3/2, this is 1/2, this is 1, this is 3/2. All right, so if I do that, and my first equation, y-intercept of 1/2, goes down -3/2. So the cool thing about scaling up or down is you can still go the same number of boxes, and as long as you scale the x and y axis by the same amount, and you're good. So -3/2 brings us down here. I went 3 boxes down, 2 boxes to the right, which is fine. Normally you'd have to scale that and say go 6 boxes down, 4 boxes to the right, but this will also be fine. So that's my blue function. And it's going to be a solid line. All right, our next function is going to be a dashed line. So this is going to be plus 2/3. 2/3 is slightly more than 1/2. So plus 2/3 is going to be, it's not going to be a solid dot, it's going to be an open dot. And then from there I'm going to go -2/3. So -1, 2/3, 2, 3. So it's going to be right about there. And connect that with a dashed line. All right, got the slope right. It's going to be a dashed line, and x is less than 3. That's going to be a dashed line as well. And I go over 3. It's going to be somewhere over here. I'm going to say that this is at 3 right here, and less than is going to be left. All right, so my function, what does it look like? So blue is going to be on, our first function is going to be top or bottom. Did you guys find that already? Y is greater than, so top or bottom?
Top.
Oh, top, yeah.
Top, so in that direction for our blue. And then for black, that's going to be top or bottom. Y is less than bottom, so it looks like that. You can see where it intersects. And then we don't have a really top or bottom for x. It's going to be left or right, and you guys can obviously see it's going to be
Left.
left, yeah, the negative numbers. So it goes in this direction. Cool, and then we have our solution, which is this triangle shape down here that ends at x equals 3. Cool, and then you could see how if you kept increasing the size of the number of functions, if you had like 13 of them, you could get it narrowed down to a pretty small little shape, which is the idea behind the treasure hunt that we're doing this week sometime.
But wait, I thought we were supposed to graph it on the map. We're graphing it.
Yeah, so we're overlaying a map on a coordinate plane,
Oh.
and I will tell you what that coordinate plane is in advance, so we all have the same map.
Is there one treasure or multiple?
That's a good idea. What would you guys prefer? Should I make multiple and make each one a different degree of hardness?
Yeah, seems like better.
Like one you have to do like 13 inequalities and it's like 5 points versus one they have to do like 3 inequalities and it's 1 point. That'd be cool. I like that.
The problem is this gets extremely complicated with paper because 13 different inequalities on the same map.
I can print out multiple of the same map for each problem. All right, so that concludes the notes. You want to say hello or goodbye to Claire?
Goodbye.
Ben says goodbye. Arrow waves. All right, see you later, Claire.